So today we're going to practice creating what's called a Maclaurin polynomial. And this word Maclaurin, all it means is that we are going to create a polynomial that is centered at 0, or what that means is when we come up with an equation of a line or a quadratic, it's tangent to that function at 0. So Maclaurin just means it's centered at 0, and we're going to come up with a shortcut for creating all of these polynomials. So this is my function, e to the negative x. This n equals 5 tells you what degree the final polynomial should be. So I'm going to come up with the 5th degree polynomial that is a good approximation to e to the negative x. So first thing I always do is you will need to come up with the first 5 derivatives. So the first, I'm going to rewrite the function, and then my first derivative is negative e to the negative x. Second derivative is e to the negative x, etc. So I need the function and the polynomial to have the first 5 derivatives to be the same. This is centered at 0 because it is a Maclaurin. That's what that word means. So if I evaluate all of these at 0, this is 1, negative 1, 1, negative 1, 1, negative 1. Notice it just alternates. So my 5th degree polynomial that approximates this function would be, you start with the first term, which is 1. Then you're just going to go down. The next term has the first derivative in it, so it should be minus 1 x to the first over 1 factorial. Obviously, I don't have to write the first, I don't have to write the 1 factorial. Then your next term will have the second derivative, which is also 1 x to the second over the second factorial. So notice the derivative matches up with the power on the x, matches with the factorial. So the pattern continues, minus 1 x to the third over 3 factorial. That was my third derivative. Go to the fourth derivative, which is 1, x to the fourth over 4 factorial. Fifth derivative, minus 1, x to the fifth over 5 factorial. So this is my 5th degree polynomial that approximates e to the negative x. Okay, I'm going to jump down to number 3 actually. Okay, so the function is sine of pi x. I want a 3rd degree polynomial, so I need to start by coming up with the first 3 derivatives. I need the value of the function as well, so I just rewrite it. First derivative is pi cosine of pi x. Second derivative is negative pi squared, because I need to chain rule on that pi x. Third derivative is negative pi cubed cosine of pi x. I need to evaluate this at 0, because a Maclaurin means that you are centered at 0. If I plug in 0 into all of this, this is 0, this is pi, this is 0, this is negative pi cubed. So my 3rd degree polynomial is, I start with the first term, which is 0. I'm going to write it even though you don't need to. My next term should have the first derivative in it, times x to the first over 1 factorial. The next derivative is also 0. It's 0x squared over 2 factorial. My 3rd derivative is negative pi cubed, x cubed over 3 factorial. Again, you don't have to write the terms with the 0, so really you can just rewrite this as pi x minus pi cubed, x cubed over 3 factorial. This is your 3rd degree polynomial. Let's try one more, going back to number 4. Okay, I'm going to come up with a 3rd degree here as well, so I will need to start with the function, and I will need to come up with the first 3 derivatives. Second derivative, bring down the 2, reduce the power by 1, chain rule, secant x, tangent x. I would probably simplify to this, 2 secant squared tangent x, in order to get to my next derivative. The 3rd derivative, you will have to use the product rule. I'm going to pull out the 2, and if you use the product rule correctly, it should look like this, plus secant to the 4th x. Again, I am centered at 0, so I'm going to plug in 0 for all of these values, and then this is going to give me 0, this is 1, this is 0, this is 2. So, again, I'm going to come up with the 3rd degree, and this time I'm not going to write the terms that is 0. So my first term is 0, I'm not going to write that. This is my first derivative. So first derivative times x to the first over 1 factorial. Again, you don't have to write the 1 factorial or the power of 1. My next term is 0, so 0x squared over 2 factorial. I'm not going to write that. The next term comes from the third derivative. So there's my third derivative, x to the third over 3 factorial. This is my third degree polynomial.